Oh, we are really the same time. Oh, wow. You know, I
It's like an online review.
Yeah.
Are you not? Okay. Oh. Yeah, just keep it. I will. Should I go? Yeah. Okay. Hi, everyone. We're gonna get started. So welcome to CSM 61A Midterm 1 review. We'll be presenting today, and feel free to ask questions if you have any while we're presenting. So I'm Christina Fan. I'm Ashley Chiu.
I'm Christina Yao.
I'm Mihir Mirchandani.
Okay.
Okay.
Okay, so just before we start, a quick disclaimer that CSM is not officially affiliated with course staff, and the presenters are representing CSM regardless of their position in other organizations and courses. So please direct all logistical and assignment related questions to ed and course staff. So first we'll start off with control and what would Python do, and I'll be presenting around half of the slides, and Christina Yao will present the other half. Okay, so to start off, for Boolean values in Python, we have both falsy values and truthy values. Falsy values are as listed false, 0, none, and an empty string. And truthy values are values such as true, positive integers or numbers such as 1, also negative numbers like -1. Strings like hello and almost anything else. So floats can also be truthy values, for example. We have these two Boolean kind of operators, and or. And so and evaluates to the first falsy value or the last truthy value, and it stops evaluating there. So for a sort of example you can think about using and would be in kind of normal language lingo would be are you free Saturday and Sunday? And or evaluates the first truthy value or the last falsy value and stops evaluating there. So one sort of example using common language would be are you free Saturday or Sunday? When we evaluate using Booleans, we evaluate in this order of precedence. So first we evaluate expressions containing a not, and then we evaluate expressions containing and then finally we evaluate containing or. You can think of this as order of operations, but for these operators instead of with math, operators like addition and subtraction. For the and or we also have short circuiting. So basically what we want to do with short circuiting is do as little work as possible. And so when we short circuit with and, when we have false and then anything else, we just stop evaluating at false and we will return false as our value. Here we don't short circuit because we don't have any falsy values, so we will just return true. Here we have true and false. And so we can't short circuit at true because that's a truthy value. So we're just going to return false at the end. For short circuiting with or, remember or short circuits at the first truthy value. So when we have true or anything else, we're going to return true. And so we just short circuit here and we don't evaluate the rest of the expression. When we have false or true, then we're going to return true because we can't short circuit at the false. And then when we have false or false, then we're just going to return false. You can replace true or false with any truthy or falsy value, and Python will still evaluate it in the same way, but it'll return the real value instead of true or false. So for example, when we have none and anything else following the and, none is a falsy value. So instead of returning false, we're going to return none. when we have true and one and hello, none of these are falsy values. So we're just going to return the last expression, which is hello. And then when we have true and 0 and 1 and true, we short circuit at the first falsy value, which is 0. And so we just return 0. For short circuiting with or, we have when we have, for example, 1 or anything else, or short circuits at the first truthy value. So we're just going to return 1. When we have false or 1004, we're going to turn 1004 because we can't short circuit at false. So we just return the truthy value. And when we have 0 or none or an empty string, all of these are falsy values. So we just return the last falsy value, which is the empty string. Note that when we're short circuiting, not every expression is evaluated. So for example, nothing is evaluated after the first falsy with and. So if we have false and 1 divided by 0, then we're going to return false. And we don't evaluate anything after the and. If we have 1 divided by 0 and false, we will evaluate the 1 divided by 0 and we'll realize that's a 0 division error, division by 0. So we also won't evaluate the rest. For short circuiting with or, nothing is evaluated after the first truthy value. So if we have true or 1 divided by 0, we will return true because we short circuit after the true and we don't evaluate anything else after the or. Similarly, if we have 1 divided by 0 or true, then this will return a 0 division error because we have 1 divided by 0, which causes the error, and we don't evaluate anything else after that. So for control statements, we have if, elif, and else. And for if, we usually can only have like one if statement, and this is not optional. So if we want to make some sort of control, we have to use an if statement. Elif is optional, and you can have 0 to infinity elif statements. So you could have like if something, elif something, elif something. But you don't have to have an elif statement. And then for else, else is also optional. So you can either have 0 or 1 else clauses. So you can have like if something, else something, or you can just have an if clause by itself. And finally, we have a few what would Python do tricks. So when we have print of x, this prints x to the terminal. And then if x is a string, then we print it without quotation marks. So if we have print hello there in quotation marks, then our terminal will output hello there without quotation marks. And the return value of print is none. So print x will evaluate to none. And then return x, when we see this in our function, it stops execution and it causes the function call to evaluate to x. So if we call something and it returns x, then that function evaluates to x.
Hello, I'm the other Christina. So now we'll be going over some practice problems for what would Python do. So go ahead and take about like 4 minutes and turn to the person next to you and then work on these and then we can talk about it afterwards. Yeah, talk to the people next to you.
Oh, yeah, actually, it's there. Oh, yeah, yeah, right now. Yeah, because the square gets cut. Okay, so that they so the square equals one.
Okay.
Yeah. They kind of want everything to come together. Well, I never like this, you know.
Yeah, whereas that's like a brown with coffee, everything away, you know, like with her as London. It is two square feet in one. So, yeah. Yeah.
Okay, everybody, I'm gonna start going over the problems now. So yeah, it's okay if you didn't have enough time to finish. I'll just start going over the first one. Okay, it's okay. So to start off with the print statements, we always want to evaluate from like the inside out. So we're going to evaluate this inner print statement first. Let me see if I can draw this. Yeah, so we're going to evaluate this print statement first, print 2, and that is going to output 2. And then after that, this print 2 statement has a return value of none. So the actual value of the statement is none. And then we're going to print 1 comma none. So we're going to get 1 and none. Oh, shoot. I should probably just go to the next slide. Wait, how do you go to next slide?
I don't know why the button's not working, but you can just like click on
Okay, there we go. Yeah, so first we're going to print out 2, and then we're going to evaluate the outer print statement, so we'll get 1 and none. Does anyone have any questions on this one? Okay. For the next problem, we're going to evaluate Argentina 0. And so looking at this function, we're going to first print 0 in this case, and then since our n is 0, n is not greater than 0, so we're going to go to the else case, and we're going to return 1/0. But since 1/0 causes a 0 division error, the next line is going to error. Any questions? And finally, for the last function call, we're first going to evaluate Argentina with n equals 1. And so we're going to print n to print 1 out. And then since 1 in this case is greater than 0, we're going to return a lambda function, which takes in a k and returns the function k applied to n plus 1. So this Argentina 1 is going to return a lambda function. And that lambda function is going to take in k, which in this case is square. And it's going to apply the square function onto n plus 1, which would be 2. So the square of 2 is 4. And so the function itself is going to return 4. Any questions? Okay. Moving on, we're going to talk about while loops. So while loops are used when you want to repeat a certain chunk of code multiple times, as long as the condition is still true. So this is a general format for a while loop, and the function, the body of the while loop, will continue to evaluate as long as the conditional clause evaluates to a true value. So in a while loop, the entire body will evaluate, and then it'll go back up to the top and check if the while condition is true again. And if it is, it'll enter the while loop again. And the conditional clause is evaluated each time the body finishes executing. So again, after it finishes the body of the while loop, it'll go back up to the top of the while loop. So here's an example of a while loop. It's inside a function defined print 5. So we initialize I at 0, and then while I is less than 5, we're going to print s and then add 1 to I. So if we call print 5 on hello, we're going to pass in s as hello, and then we're going to initialize our I at 0. And while I is less than 5, we're going to print hello and then add 1 to I. So we're going to end up printing hello 5 times. So some tips to work with while loops: make sure that the condition is changing with every iteration of the while loop, or else you'll get stuck inside an infinite loop. So for example, in this case, we're incrementing I by 1 each time. So eventually it's going to hit 5 and then it won't enter the while loop. Another thing is to use if you use a return statement inside the while loop, it'll stop the loop immediately. So it won't go through the while loop for every iteration. So be careful if you want to use a return statement inside the while loop. Okay, so the next set of problems is also what would Python do? So go ahead and take a couple more minutes to work on that, and then we'll go over the answers.
Excuse me.
Okay, so it's once again, I think everyone's starting to wrap up now, so I'll start going over the first problem, which is maths 2-3. So when doing what would Python do problems, I think that it's a good idea to draw the environment diagram if you're ever confused, especially because as you can see in this problem, there's like a lot of like functions with the same names, and also they take in like an argument with the same name. So I think that drawing out environment diagram helps you differentiate between like what's a function and like what the function value actually is. So I'll start by drawing out like a simplified version of a environment diagram. So the first thing that happens is we define a function called quick maths, and then also another function called maths. And then this is going to be pointing to a function object, quick maths. It takes in fast and maths. And same thing here, a function object with the parameters fast and maths. And since these are functions, we're going to draw an arrow to the function objects. And now in our last line of code, you can see that the value of quick maths and maths is assigned to the value of maths and quick maths. So can anyone tell me what would change in our environment diagram with this last line of code here? Yeah, exactly. So the arrows would switch, and they would switch at the same time. And this is because in Python, you can simultaneously like swap the values of these two variables. Okay. So now the variable name maths is bound to the function quick maths, and quick maths is bound to the function maths. Yeah.
Could you do that, like how you assign two variables at the same time? Did you do it with like 3 or 4, or is it just 2?
Yeah, you can do it with yeah, you can do it with multiple variables.
Okay.
Yeah, and it works with not just functions, but also like if you had like just integers or like strings. Okay, so now that we have we kind of know what quick maths is in terms of like its function and also maths, we can start evaluating our first problem, which is maths 2-3. So if we go and look for maths, we can actually see that it's bound to this function quick maths. So this is the function that we're going to be evaluating.
For the switch part, it's called like
Mhm.
math.
Yeah.
If we do that separately by like A equal to B and B equal to A, it will fail to switch these two, but we can make it together in Python.
Yeah.
And if we need to do it separately, we need to use the C for as a, to do that.
Yeah, so the question was, since we're doing it on the same line, we can do it simultaneously, but if we were to switch quick maths or assign quick maths to maths and then assign maths to quick maths, it would fail because we would already have reassigned the first value. So we would need a temporary variable, like you said, C.
It's because when we are doing this, the math memorize what quick math originally is. And it will also always find the original value of quick math and that into itself.
Yeah, yes.
Thank you very much.
So now with that information that we can switch them both at the same time, we can start evaluating maths 2-3. And looking at the variable maths, we can see that it's bound to the function quick maths, which is this function here. So we're going to enter this function body. And in this case, since 2 is our fast and then 3 is our maths, we're going to do 2 to the power 3, and we're going to get 8. Any questions on this first problem? Okay, so moving on, we're now going to look at the function quick maths, which is actually bound to our function maths, which will be this second function right here. And in this case, quick maths takes in print and 10, and it returns fast applied on maths and 2. So looking at this, it can be a little confusing, especially because we have like all these different variable names. So we'll start by looking at like the arguments passed in. So in this case, print is going to be our fast. So I'm just going to write it here. and then 10 is going to be our mass. So now that we know what our arguments are in this function, we can look at the return statement, which is fast applied to maths and 2. So since we have print as our fast and 10 as our maths, we will print out 10 comma 2. And in a print statement, if there's a comma between two things, it just separates them with a space. So we will be printing out 10 and 2 separated with a space. Any questions on this problem? Okay, and finally, we're going to look at quick maths on maths and 10. So in this case, since we're using the function quick maths, again, we're going to be using this maths function. And then this maths right here, looking at what it's bound to the function quick maths. So where this is actually going to turn into quick maths for this problem, and also it won't be 10. Oh wait, it is 10. The second argument is still 10. So yeah, the function we're using in this case is quick maths. Any questions so far? Yeah.
So can we go back to the second problem?
Yeah.
We're returning like rings 10 and 2.
Mhm.
That'll also like be line where we're returning
Yeah, exactly. So in this case, since we're not printing like the return value, we're not going to actually get that none. So whenever you, sorry, go say that again. So when you return none, it doesn't output anything into the terminal. But like, for example, on the previous slide, if you remember, we were printing like 1 and none. So then it would print out the actual word none. Okay, so going back to this problem, quick maths on maths and 10, maths is going to be bound to our function quick maths, and then the 10 remains the same. And now we're going to return quick maths on maths and 2. So quick maths is going to be our first function, and we're going to apply 10 and 2. So this is going to be 10, and this is going to be 2. And now we're going to evaluate this function, and that will be our return value for the whole problem. In this case, since our fast is 10 and our maths is 2, we're going to do 10 to the power 2, and we're going to get 100. So going through that one more time, quick maths is bound to the actual function maths. So we're going to look at this function first, which takes in maths, which is bound to quick maths. So our fast is going to be quick maths, and then our maths parameter is going to be 10. And then we're going to return the result of quick maths applied on 10 and 2. And that function basically does 10 to the power of 2, which gives us 100. Any questions on any of these problems? Okay. Does anyone have any questions on what would Python do in general before we move on to the next topic? So in general, like the biggest tip I would recommend is to always draw like the environment diagram, even if it's not like super clean. You can just do like a rough sketch for the exam. And I think that would really help with when they like try to confuse me with multiple like functions or variables with the same name. Is everyone okay with me clearing this?
Like welcome to the like S1 data.
Sorry, I just realized I was muted. So we're on to environment diagrams now. So the rules include frames, which always start with the global frame. And whenever a function is called, we kind of move on to new frames. So another frame can be opened with like calling a function like min or sum or a function you define in your code. And when looking up a variable, we basically want to look up a variable in our current frame. And if that variable does not exist in our current frame, we refer back to the parent frame. And we kind of repeat this until we reach the global frame. So does anyone have any questions about this slide? Okay. Okay, so just some more rules. In an environment diagram, we kind of draw a box to indicate that we are working in a frame. Usually, as soon as we run a program, we start off with our global frame, and then we write out our variables in the order at which they're kind of defined. So as we can see here, primitive types like numbers, Boolean, strings, they go directly into the boxes. So if we have something like a equals 3 in our code, we basically write out a, and in our box we write 3. Whereas with functions, lists, and other things that need a pointer, what we do is we actually draw a pointer and we write out func. And in this case, we defined a function called f. In this case, f has no parameters, and our parent is always global in this case because we're not inside another function at the moment. Yeah, so does anyone else have any questions about this? Okay. Awesome. Okay, so let's look at defined statements. They don't evaluate to a function body when they are being declared. They instead only evaluate to like a new frame when they are being called. So basically, you only need to open a new frame when that function is being called. The parent of a new function is the frame in which it was defined. Okay. Call expressions. So we have 3 golden rules of evaluation. We have evaluate the operator at which the function is being applied. Evaluate the operand or operands, which are the arguments. You want to first address those. And then finally apply operator to operands. This is when you open a new frame. And whenever we open a new frame, we label that frame with the intrinsic function name and parent frame. Whenever you open a new frame, you don't have to necessarily write out the parameters, but you just have to write out the function name. And if you're actually writing a function frame for a lambda expression, you want to explicitly state the line number because there is no intrinsic name. And finally, you want to set formal parameters in the def line to the arguments passed in the call line. Sorry. Does anyone have any questions?
What is a function not connected to like the global, like parent equal global? Like when is it like parent equal F1, F2?
Okay, that's a great question. So basically, when we are defining a function within a function, for the most case, we will have kind of this idea of parent not in global, but parent in F1. And that's when it's defined. When you're calling it, it always is basically where it's defined, but where it's defined could be inside of another function, not necessarily in the global frame. Hope that makes sense. Yeah.
I feel like sometimes define lambda functions, like what if you just put it like in your code, but it's not really in another function, would it just be in the global frame?
I see. So where would it be located inside of a function, or would it be
Just like not inside the function?
not inside of
It
so
would just be in the global.
on its own? Yeah, it's just in the global frame. That's correct. Parent equals global, and just make sure that you have the line number because lambdas do not have any names associated with unnamed functions. Okay, any other question? Yeah.
Can you set like a value equal to a lambda function?
Yes.
And then call the value later?
Uh-huh.
For the line number, do you put the value that the line that is called out or the line that the lambda function is created?
That's a great question. It is where the lambda function is created. Yes. Any other questions? Okay. So here's a warm up for everyone. We'll work through this one together, and then finally we'll go through a later example to get on your own. Yeah, so first let's start off with this. A equals 1. We're defining a function b with a parameter b. And then we're going to make two calls to b, a equals b a and a equals b a. So let's kind of dissect this. First, we write out our global frame. So notice in our code, or actually our code is also right here. A equals 1. So 1 is an integer. So we can actually just put it inside the box. Our function b, however, needs to have a pointer associated with it. Recall we're doing func, the function name, all function parameters, and parent equals global. So you need to make sure you have all three things. And we aren't explicitly saying the return statement yet, but we will be moving on to line 4 directly. So now we have a equals ba. So this suggests a function call actually, because we are calling b now, a function we have defined. And so this kind of creates a new frame in our environment diagram. That's our next step. So line 4 creates a new frame in our environment diagram. Does anyone have any questions so far? Okay, so we're on to frame 1. And notice we see that we put b, but we didn't put any parameters. Just make a note of that. And always copy parent equals global with kind of what you define. The parent equals global in the global frame and the parent equals global in the F1 should always match. And always, whenever we open a new function frame, we always address the parameters first. So our parameter for b is actually another b. So basically, in our code on line 4, we said a equals ba. At this point, a is actually 1 at the moment, right? So we're doing b with a call on a equals 1, and we're putting that into our parameter b. So here we say b1. Does anyone have any questions? Okay. Next, so next, I think we go into the return value, which is return a plus b. At this point in frame 1 still, do we have any variable a in frame 1 defined? Everyone should be thinking, no, we actually do not have a in frame 1 defined. So in this case, we would refer to our parent equals global. And in our global frame, we do have a as 1 actually back here. I'm so sorry. Yeah, okay. I think I skipped the slide. Okay, so back here we have a as 1. So that's why our return value is actually 1 plus 1, which is 2, which is right here. And notice on line 4, we actually say a equals ba. So we are actually mutating our global variable a. So a is no longer 1, it is now 2, because our F1 return value was 2. Does anyone have any questions? Okay. And that is just line 4. Now moving on to line 5, a equals ba, we are making a new function call. So for F2, we are making a new function call, but why is our parent not equal to F1 in this case? Can anyone answer that? Why is our parent still global? Exactly. Just because the frame right above is F1 doesn't mean the frame right below should be a parent directly to what's above, right? our parent is still global in this case, and that's because that's where we defined our function, right? So yes, in this case, we are inputting A, which is now 2, right? It moved to from 1 to 2. And now we're returning A, which is 2, plus B, our parameter, which is 2. And we're returning 2 plus 2, and that is 4. So now we have a return value of 4, and we're setting A equal to 4. So as we can see here, our return value is 4, and now A equals 4 in our global frame. And that should complete our environment diagram.
So because our parent frame is global for like frame 2,
Mhm.
it doesn't, it kind of like doesn't see frame 1, right? So
It
the
doesn't, no.
B in there, like it doesn't care about that.
No, it does not.
Okay.
That's correct. Yes. And the reason why we have a B in here is because it's the parameter for our function B. We're making a call to B, and inside is another parameter also titled B. Often exams might get confusing with name conventions. I don't know why they do this. They just do this. But our parameter in this case is the same name as our function. Yes. Yeah.
For like the F1 frame, what would be one again?
Why would,
I know A is like size 1.
yes. So sure. Basically, if we go back here, inside our, you're saying it for F1, right? So here in our function F1, A is equal to 1, and we pass that in to our function call for B. So B realizes that instead of calling BA, we should kind of think of it like we're calling B1. And so that's why when we open a new function frame F1B, our first thing is to address the parameter B, and we set that to 1 because we did kind of technically say B1, right? And then what we did was we returned A plus B, and A back in our global frame is still 1, and B is 1 as we kind of inputted through our parameter. So 1 plus 1 became 2, and we set A equal to 2 because on line 4 it says A equals the return value of BA, right? And since the return value of BA was 2, A in the global frame will be impacted to 2. Okay. Yes, yeah.
But in the global frame, we change every time once like this return value.
So yes, whenever we're kind of setting A equal to BA, then we are mutating the value of A. If we just called the value BA, we're not necessarily mutating the value of A at all, right? But since we said A equals BA, that is changing, that is setting A to the new return value of our call to function BA. Does that make sense? Okay. Yeah.
If I do make some difference in the B function.
Yes.
Change the A value in the B function. So
Yes.
will the global A be changed? The value?
That's a great question. Yeah. So basically, if in our B function, right, if we defined a new A inside of our B function, what would happen is our return value would look a little different, because now return A plus B is not A, which is 1 in the global frame, but it is rather the A that is inside our function. So here, for example, if we said something like A equals 3, right, inside def B, like in the middle of lines 2 and 3, if we said A equals 3 randomly, then A would no longer be considered 1 in frame 1. It would be considered 3 now, in which case we would return A plus B, and B would still be 1 because that's what it is globally. That's how we kind of called it. But A would, in the global frame, would only change because we're saying A equals BA. So it would return 4 in frame 1 if we set A equal to 3 in between 2 and 3, for example. And then A in the global frame would change because we set in line 4, we said A equals to the return value of that.
So if I didn't pass the B to the function, but I passed the A or something, I mean, can I change the value of the problem variable?
So
And can I do change from a function inside the function to the global one?
see, I think if you have like a variable set in between 2 and 3, that is not changing anything in the global frame. That is only changing things local to the function B. So whatever kind of happens in your frame 1 with any variables in scope to your function B, we'll only change those variables and won't change anything outside in the global frame. I hope that answers the question. Okay. Okay, any other questions? Okay, awesome. Yeah, so we went through this. Okay, now this is what we call kind of like a reverse environment diagram. So we're giving you the environment diagram, but you have to come up with the lines of code that made sure this environment diagram existed. So this is kind of like a fun little exercise. I want to give everyone around 5 minutes to try this out. And let's hope we get it. And you're free to talk amongst yourselves, Gus.
Yeah, I think on my thing, I'll probably just add in like,
I'm so sorry for my Zoom people. I was just muted, but let's go ahead and dissect this. So first, I wanted to say that you have a print output box, which has two lines, flipped 160, flipped one none. Basically, this print output box correlates with where we have print calls in our script. So we notice in our print output, we have two things that are printed, which means that there are two print calls in our script. However, we don't see any print calls made, right? Which means that one of these blanks will probably have to do with printing something so that we can actually achieve a print output, right? So that's something to think about. Next we see we have a global frame, an F1 and an F2. In our global frame, we have the function flip defined with X comma Y. We see that matches very well with our script right now. We notice we have a Y with the value 1, and on line 5 or so, it says Y equals 1, so that looks good. And notice here it says A is actually none. But here we're saying A equals flip blank comma Y. But that flip blank comma Y has to be evaluate to none, right? And then finally, we have two function calls to flip. So we did actually call flip already with A equals flip blank comma Y. And then finally, on our very last line, we say flip A comma Y, right? And that probably matches with F2, right? So hopefully everyone's kind of following along as to where this is going. We noticed that we have two basically calls to flip, and we also have two things that are printed out. So what does this kind of hint at? Can anyone kind of tell me what this hints at? Any idea? Yes?
If you do the string, the value of the string is actually none.
Yes, exactly. So the return type of any print statement is always none, right? And we notice that we're making two function calls to flip, which means that, and also we're making two print calls inside our print box. So basically, we know that we probably are going to be returning a print function because A is none here. And on line 6 or so, we said A equals flip blank comma Y. And since A is none, that flip blank comma Y probably has to be none. And how we get none is through a print statement, right? So in our blank B, we know we're probably going to be printing something, right? Does this make sense to everyone? Okay, that's good. All right, so now we know that we're going to be printing something in blank B. Specifically, any ideas about what we're going to be printing?
First you put, flipped by then the X value, then the Y value, essentially, like flips, and then, what X is one.
Yeah, that sounds right. Yeah, so flip with an exclamation point. We just want to be as specific as possible in the exam so that all the syntax is good. Flip exclamation point, and then either space X space Y in quotes, or you can even do comma X comma Y, and that will autofill spaces because of the commas. Just make sure to look whether you're in quotes or not in quotes at the top. But yeah, exactly. Flipped X and Y. So that looks like it's filling our blank B. And so it looks like we're going to start off with def flip X comma Y equals Y comma X, and return print flipped X comma Y. Yeah, and then so let's kind of look at how this all works together. We first set Y equal to 1. We set A equal to flip blank comma Y, right? Now notice we have our value 1 already embedded in Y, and we're feeding that as a parameter into our first call of flip in F1. But notice here, our Y value points to 60 in our F1, and our X value points to 1. And notice this code is actually printed after everything has been executed. So it's not like first when it's kind of being looked at and you're putting in the parameters and stuff. It's also accounting for the switching, the X comma Y and the Y comma X equals Y comma X, right? So where do we get this value 60 from? Does anyone know? From A? Or sorry, from where? Oh, yeah, sorry, blank A, yes, not variable A, yes. So blank A will probably have 60, right? Because we do need to kind of print out flipped 1 and 60, and we don't have 60 anywhere in our code. So that probably hints at the fact that blank A is going to be 60. A for now in our variable sense is equal to the return value of flip, which is, as we said, will be a print statement, right? And that print statement will say flipped X comma Y. Now I just have a follow-up question actually. Does X comma Y equals Y comma X, does that actually change variables in our global frame? Or does that just change variables in the scope of the new frames we're creating with the function called flip? Does anyone have any answers?
I think just in the frame where you're probably split.
Yes, exactly. So basically when we do that X comma Y equals Y comma X, we are actually not at all changing the values of our global frame. Which is why when we say flip A comma Y on our very last line, Y is still equal to 1, right? And A is equal to none because that was the return type of flip 60 comma Y, right? Does that make sense? So I should probably pull the answer key so you guys can kind of see it better. Sorry, okay. Yeah. So we now see that we have flipped with an exclamation point, comma X, comma Y. Just want to reiterate the fact that these commas, they must go outside of apostrophes, because if we put them inside of the apostrophes, they will be printed out in the print outbooks box. So just make sure you're aware of whether your comma is inside the apostrophes or outside. Yeah, does anyone have any questions?
I have a question.
Oh, so for A, we set it equal to the return value of flip 60 comma Y. And so what happens is we see on line 3, return print flipped, comma X comma Y. The print flipped will always return none because a print always returns none. But even after all of that, we did a swap, right? X comma Y equals Y comma X, and we said Y equals 1. So in our Y in our global frame, our Y doesn't change to 60 because we do say X comma Y equals Y comma X and that swaps the 1 and the 60. So X does eventually point to 1 and Y points to 60 in this frame 1. But in the global frame, Y is always pointing to 1 in this entire code in the global frame. It's just respective to the new frames that are created through the function call flip. Does that answer the question? Okay, awesome. Great. Any other questions? Okay, finally something we've all been looking forward to. Break. Yeah, so take about like 5 to 10 minutes to just 5 minutes. Have a break.
Actually, I had a question, but I wasn't sure if you heard.
Yeah, what's your question?
Oh, okay. I was on, could you go back to the last slide?
Yeah, give me a second. Yeah,
I was wondering if, like, say in the F2 frame, there was a function that was guarded by like an if statement.
wait,
that-
1 second.
Sure.
Yeah.
Hello.
Oh, hi.
Hi.
Wait, do I ask the question?
Sure, yeah, please ask your question.
Okay. I was wondering if in the F2
Sure.
frame, like hypothetically, if like let's say one of the variables like X wasn't in that frame
Thank you. Yes.
or Y. Wait, actually, yeah. X isn't in that frame and we have to look into the F1 frame to retrieve it, right?
Sorry, which frame are you talking about? F2 exactly? Is it F2?
Yeah.
Okay, so it looks like we have X1 and Y none and return value none.
Yeah.
So you said, let's say, could you repeat your question, please?
So I was wondering in like a case where, let's say you had to look to another frame to determine like the value of X, for example.
Oh, right, yeah, yeah.
So what if like you had a situation where like for an if statement in that
Mhm.
frame, you had
Yes.
to look to another frame for the value of X, but after you met the condition of that if statement, you had like an X equals like 1 in there.
Yes, okay, yes.
So would you, like, if you had to look at X again in that
Mhm.
frame, would
Mhm.
you have to go back to the global frame, or because you defined it after that if statement, could you
Yes.
still use the one you defined in the F2 frame?
Sure, yes. I think you use the one that is defined in your F2 frame actually, because that new X that you defined will be local only to your F2 frame. So that is not actually changing anything in the global frame. That's just introducing a completely new local variable called like X that you would then kind of work with in your like new frame, like frame 2. And
Okay.
then and then anything else in the global frame won't be changed.
And the F2 frame will no longer depend on the global frame for that variable.
For that variable, yes, that's correct.
Okay, cool. Thank you.
Yeah, sure, of course. Are there any other questions? We're having a break right now, so you can kind of just ask.
If like conditions, then you're going.
All right, hi, Domenico.
Hi, could you go back to the last slide, please?
Oh, yeah, sure. Can we go back to the slide before? Thank you. Yeah, yes. Does that help?
Yeah, could you quickly just re-explain why A in the global frame returns none?
Yeah, sure, absolutely. So when we have A equals flip 60 comma Y, what is actually happening is flip 60 comma Y. If we look at the return type of that, right? What's happening is we're returning print flipped comma X comma Y, and print flipped comma X comma Y. What is the print function always return?
None.
None, that's correct. So after we print flipped comma X comma Y, we return none. And that's why A is equal to none, because basically A is equal to the return value of a call to a flip.
Okay, thank you.
Does that
Yeah, I'm still a little confused why you're printing in the first place.
Oh, yeah, sure. So if we actually look at our print output, we see that we have flipped 160 and flipped 1 none. Do you see that?
Yes.
Okay. And nowhere else in our code, we're kind of writing out print, right? So we notice we're having 2 print calls in our print output. And we also noted that we're having 2 function calls to the flip function, right? So that kind of corresponds with the idea that we'll have the print function located in the flip function. And the only place to do that is in part B. So that is why we have the print.
It's just
print
that this,
statement.
like, I guess.
Okay,
the
thank you.
translated,
Sure, of
but
course.
That would produce the same output and I think.
Any other questions?
Okay, great. I also think.
Okay, sounds good.
Okay.
Well, enjoy your break.
We'll be taking a 5-minute break, or we'll start at 6:30. Yeah.
This can.
All right, hi guys, we're gonna get started again. Today, now we'll be covering higher order functions, which is everyone's favorite topic. I'm sure. All right, so what are higher order functions? Higher order functions are functions that take in functions or they return functions. So often you'll see like nested indentation levels, and that'll signify to you that there's a higher order function in play. And so a lot of people ask, like, why do we use higher order functions? Well, higher order functions are really useful in writing short adapter functions or functions that help us connect two programs together. So for instance, if you're working through a function, but you just need like an extra parameter to keep track of while you're running it, most of the time you'll create a small higher order function within that function because you don't need other people to see that outside of that function that you're writing. Awesome. So before we get into higher order functions, let's just do a little quick lambda expression review. So we love color coding. So here we see that when we write a lambda expression, we have to write the keyword lambda, we have to write our parameters, and these parameters will usually be separated by commas, and then we have to write a colon. It's really necessary to write a colon because everything that follows that colon on the right side will be the body of the function, and that body represents the return expression of that lambda. So that's the cool thing about lambdas. They don't really have bodies, they just return things. So yeah, lambdas are really cool. They're anonymous, so there's no intrinsic name, and they're written in one line. And if you color code it and like translate it a little bit to English, it says a function that takes in all the parameters and returns the body. How do you feel about that? Good, awesome. Let's keep moving then. All right, so the first thing that we'll kind of do is we'll do a little bit of review with lambdas. So we see that we have this function A, and then we have D equals 5, and then we have a call on A. So we'll be, if you have the slides open, we have a Python tutor link, but it's okay, I'll be going through it with you as well. So here we see that when we start our Python tutor, we see the first line, which is, we see the A, which will be, it will point to an intrinsic function called A that passes in a Y. And then because Python, as Mihir went through with environment diagrams, it'll skip through all the function body and return and go to the next line that's on the same indentation level. So that's how you can see it on an exam. You line it up and you'll see like exactly where the next indentation level is, or like the same indentation level is. And that's the next line of code you execute. So we see D equals 5, which we execute. And then now we see this really long function call A, and we pass in lambda x 4 minus x plus D. So what we first do is we bind variables in the global frame to their values, which is what we did with the function A and then the variable D. And then what we do is now we need to open a new frame, right? But let's like take a pause really quick. Before we open this new frame, there's a few very important things that we need to do. First, we evaluate the operator, which is A. So A is our operator because that's the function that we are calling. Then we need to evaluate our operands, right? So what do we pass into A? We pass in a lambda function. And so this lambda function is the operand to the function A. And when we're evaluating this is all before we create our new frame, right? So this is all done in the global frame. And then now, because we've evaluated our operator and our operands, we're now ready to create our new frame. And that's how we get F1A with Y, which is our parameter for A, pointing to an intrinsic function lambda. And so quick question for all of y'all, is the parent of this lambda function F1 or is it the global frame? All right, yeah. So it's global because what we do is we first evaluate the operator and evaluate the operands, and then we create the new frame. So we do all that evaluation in the global frame before we create, and that's how we have the premises to create our new frame on. We need to already know what the function and the parameters are before we create that new frame. So the parent is global. Yeah, all right. So then now, once we have created this function in Python, we can now move on. And so we can see, the next thing that we do is we define D equals 1, B equals this lambda function here with parent equals F1, E equals this lambda function here with parent equals F1 as well, because it depends, your parents are where you're defined, not necessarily where you are called. And so another cool thing that Mihir noted is that you want to write which line number you're using for lambdas, because as you can see here, there's 3 lambdas. And if you didn't differentiate which one it is, it would get pretty rough later on evaluating. And then now we know that the next thing we want to do is we want to return E of B, right? And so the problem here is we want to now call E of B. And so E is our operator. So we evaluate that to be the function lambda on line 4. And then B is our operand. which is the function lambda on, or like the lambda on line 3. So this opens a new frame. Once you have all of that evaluated, this now lets you open a new frame. And so that's how we get our lambda, our F2 frame, which is a lambda frame. Great. And then once we do that, what happens is because E of B returns, it returns B passing in 3, right? Because here we see that E equals a lambda x passing in 3. Because we bound B to x, we now call B of 3. And so this opens a new frame once we evaluate the operator and the operands, and we get the frame for the lambda on line 3, which is B. And now we see that x that's passed in is 3. And then we need to figure out what the y is, right? So can someone tell me what the y is on this frame? Or how we would go about finding this y, the y that we need? Yeah, go for it.
Yeah, so you look in the current frame and it's not there, you look in span.
Yeah, perfect. Yeah. So just to reiterate, what we do is we look in the current frame. And so the current frame we're in is F3. Sorry, it doesn't label it. But we see that here in the F3 frame, which is the lambda on line 3, we don't see a y. And so we trace it back to its parent frame, which is parent equals F1. So now we look in the F1 frame and we see that y points to a function, the lambda on line 7. So that's the one that we want to execute. We want to execute y of x. And because y points to the lambda on line 7, we now need to open a frame on the lambda on line 7, which will now correspond to, and then because we passed an x from F3 where x was 3, now the lambda on line 7, when we pass in that x, it is also 3. So we say 4 minus x plus d, we pass in that x, which is 3. And then like we did before, because we don't see a d in this frame, we note that we now want to go to the global frame. Sorry, it doesn't label it, but this line 7, the parent is global. So then we go up to the global frame and we see that d is 5. So then we do 4 minus 3 plus 5, which is 4 minus 3 plus 5, which is, I just muted myself. Okay. Yeah, awesome. So then when you do that, everything closes. So when you close the frame, you can't access that information anymore. And then, yeah. So that's like the end of just doing that one function call. How do we feel about that? Okay. Do we have any questions about it?
Oh yeah, I have a question.
Yeah, I'd recommend looking through the Python tutor and like clicking back and forth. It's really helpful. Yeah, but yeah, just like a keynote there is that the lambda on line 7, the parent is global, not F1. Yeah. Okay. What questions do we have?
Oh, why is the parameter its parent function not F1 but global for lambda x?
Yeah. So the D in the lambda, in that like last F4 frame that we use, the D is 5 because the parent for that frame is global. And because there's no D here, we look into the global frame. So we don't have to look into F1 because F1 is not the parent of that frame.
So there's no place for us to write that D because we haven't created any local D or something. It's just we use a global value. So it didn't make any sense. So there is no other D in this.
Yeah. So when we look for variables in our environment diagrams, we trace from where the function, like the current frame is that we're working on, and then we go to its parent frame. Yeah. So if there was no D in the global frame, this would have caused an error. Yeah.
And the first lambda is the lambda at 4 minus 7, not C.
That's the lambda on line 7. Yeah.
So why the lambda right from line 7 is straight at the bottom?
Because that's the last one that's actually called. So for frames in environment diagrams, the name of that frame is the function that's being called, and we don't actually call that function until on line 3 we see that we call like y of x. So at some point you see in F1 y points to that lambda, and so that's when that lambda is actually called. Like you open a new frame when you call a function, and so you're calling that function because you see the parentheses that signify a call.
But we have learned in class that Python will first check the variable given to the function and then do the following step. So why is not checking, why is not finding what lambda x or minus x plus b is, even if they didn't create anything in it, but they do need to check lambda x or minus x plus b. It's just like the same question. If there is some error, some variable given to a function which will lead to error, but the variable hadn't been used in the structure of the whole function, it still give us back an error because we will check the variable given to the function first. So I think it's the same logic. So although we will last find what is lambda x is because we never use it. First is b and the second maybe is e, but we still need to check it first. So why is not written first?
Oh yeah, that's actually a great point. So we never check functions. Like, so when Python sees a function or a definition or a lambda signature, it never reads anything past the signature, which is the name of the function, which in the case of the lambda doesn't have a name, and the parameters. Python doesn't ever go through the body of a function until it executes that function. So when it's called. Yeah. So just when it's written there, you won't actually see Python doing anything. Like, so if we go back to where it defined A, we see that we define A, but it doesn't actually step through that function at all. It completely skips everything in that function and goes to the next line, which is d equals 5. So it doesn't need to check if those variables exist, if there's any variables there that don't exist, or if there's any problems with them, if there's a zero division error. We don't check any of that until the function is actually called. Yeah. All right. How does that? Yeah, what's up?
I mean, the only thing that I was just making some was like the part with like the return b of b.
Mhm.
So like, are you just plugging like a lambda function into a lambda function? Is that kind of what's happening with that?
Yeah, so for e, when we see e equals lambda x of on x like passing in 3, so what we see there is that we're passing in the lambda that we assigned to b as the parameter x, and then we're calling b of 3.
Because like, aren't we getting kind of like? Oh, sorry. Okay.
B is what you're calling B to E lambda function, so like
Yeah.
imagine you're putting B where the X is, but B is just another lambda function. So then you're calling this new lambda function on 3, which is you plug in 3, so it's Y of 3. Okay. Yeah, it's like a lambda error.
Yeah.
All right. I'm gonna move on really quick. Sorry about that. But please send any questions you have on the ed. We'll answer any questions that you have on the ed STEM as well.
Okay.
Yeah. All right. I'm gonna skip through this really quickly. Let's go on to this question. So it's a higher order function, specifically in one where you have to write the function yourself. So write make alternator, which takes in two functions f and g and outputs a function. When this function takes in a number x, it prints out all the numbers between 1 and x, applying f to every odd indexed number and g to every even indexed number. So we see an example on the right where we see that a is this make alternator passing in the squaring function, and then for g, it passes in x plus the lambda where it returns x plus 4. And we see if we call a of 5, so when we start with 1 is odd, so it'll square it, so it passes in 1. 2 is even, so we do 2 plus 4 is 6. 3 is odd, so we do 3 squared, which is 9. 4 is even, so we do 4 plus 4, which is 8. And then 5 is odd, so we do 5 times 5 is 25. All right, I'll give you guys maybe 5 or 6 minutes to go through this question, and then we'll take it up. All right, feel free to work in groups. Okay, all right, we're gonna get started now. It's okay if you didn't finish. This question is kind of difficult. Yeah. All right, so this question, we wanted to take an approach of walking you through exactly what we would think of how to write the question and how we would solve it in what order. So let's get started with the first part. So we see that we have this def statement here. And then our main question first is, what does make alternator f comma g return? So what's the return type of this method? Yeah, great. It's a function. So this means that we have a higher order function because we need to return a function within a function. So that's the definition of a higher order function. Perfect. So that means that on our, on this line here, we need to define our inner function. And on this line here, we need to return that inner function. Yeah, like this. All right. So that's the answer to our question. Make alternator returns a function. And then our next question is, how can we iterate through the numbers 1 through x? Yeah, go for it.
You said I equals to 1, and then you put it in a while loop, like while I is less than or equal to x.
Yeah, perfect. So we need to set a indexer, which will say I equals 1. And then we'll set a while loop that while I is less than or equal to x. And then within this while loop, we need to do something that'll print out the result of some function. And then at the very bottom, we need to increment x so that every time we're going through this looping process, x is increasing by 1. So this will get us through 1 all the way up until we get x. Perfect. Our next question is, how do we check if I is even or odd? So this has a lot to do with how we do digit manipulation. So yeah, go for it. Yeah, perfect. We want the mod. So how do we check if it's even or odd? Yeah.
You do, like if I mod 2 is equal to 0, then it's equal to 0.
Yeah, perfect. So if we see that if I mod 2 equals 1, this means that if we divide the number I by 2, there's a remainder of 1, which means that it's odd. So we create this statement up here to say, okay, if I is odd, then we need to execute something. And then if else, so this means that I is even, then we need to execute something completely different. So these are 2 test suites, basically, of how we want to run our code. So yeah, perfect. So a lot of the times our digit manipulation or checking for whether a number is even or odd, divisible by something, something like that, we always use the modulo, which is the percent symbol. Then our next question is, how do we print the results of f of I or g of I? This is kind of a trick question. Yeah, go for it. Yeah, perfect. So we want to print f of I or print g of I. So if I mod 2 equals 1, this means that I is odd. And in this case, we want to print the result of calling f on I. Else, this means that I is even. And this means that we want to print the result of g called on I. Yeah, so this is our entire function. We hope that this walkthrough of asking what questions we would ask ourselves and how we would go about solving the question would really help. What questions do we have on this question here? Or the solution, rather? Yeah, go for it.
Could you also switch it? So if you wanted to do I mod 2 equals 0, then just print g of I and then else print f of I?
Yeah, perfect question. Yeah, perfect question. You can do either way, so long as you do this if else scenario. Yeah.
Sorry, so since
What
your
other questions do we
alternator
have?
doesn't have a return, functions
So
don't
Patricia,
need.
check, how do we like this question? This makes sense. Help. Okay. Sounds good. All right. I think we may have time to do one more, but I'm not sure. We may go a little bit over if that's okay. All right. So here we have a really long question. Implement forbidden digit, a higher order function, which 1 takes 2 arguments, a function f and a digit forbidden, and 2 returns a function that takes in 1 argument and returns the following. So these are our conditionals. If the return function is passed a number where the digit in the ones place is equal to the forbidden digit, it should return the result of calling the given function on the number without that final digit. Otherwise, it should return the result of calling that given function on the number. So if we see on the right-hand side, we see g equals forbidden digit lambda y 200 floor div y mod 10, and the forbidden digit, and we pass in the forbidden digit of 0. And then we're passed in 11, right? So 11 mod 10, or sorry, 11 does not end with 0, right? So what we do is we just return the lambda function passing in 11. So So we get 200 floor divided by 11 mod 10. 11 mod 10 is 1, because if we do 11 divided by 10, we have a remainder of 1. So we do 200 floor div 1, which is 200. All right. I will let you guys have like 3 or 4 minutes on it, and then I'll go over it. Sorry, I know that will not be enough time, but we want to get through this question. Yeah. All right, go for it. Talk in groups. All right, I know that was not enough time, but I want to just like go over it. Yeah, awesome. So let's start by filling in the code. So here, oops, sorry. Here is our, the first step is telling us what do the doc tests tell us. So specifically, it might be helpful to draw an environment diagram, especially on an exam, to figure out what happens specifically when you go through a doc test. If you don't understand the doc test, it's kind of hard to do the question, even if you've read the spec. Yeah. So here is our function written out nice and big on the left. So if we start, we see that we need a, we have an inner function, def forbidden wrapper of n. And then we note that one of our keys into how we should check, like whether we should call f, or sorry, f on the number itself or f on the number without the last digit, is that we want to check if the last digit of our number is the forbidden number, right? So how do we check if our last digit of n is forbidden? The number for like the number forbidden that we're passed in, the digit. Yeah, perfect. So if n mod 10 equal forbidden, then this means that we want to return the function call f on n without that last digit. So how do we do n without the last digit? Yeah, go for it. Yeah, perfect. So we want to call f. So here, if n mod 10 equals the forbidden digit, then we want to return f and then passing in n floor divide by 10. So this is a case where we see on the right g of 10. So because g of 10 ends in 0, what will happen is we'll return 200 divided by, and then y will be 1 because we'll have chopped off that last 0. 1 mod 10 is 1, so 200 divided by 1 is 1. Oh, sorry, 200. Yeah. All right, and then now let's build our else case. So in the else case, if the last digit of n is not the forbidden digit, what do we want to return? Yeah, f of n. Perfect, everyone. Slay. All right, so we return f of n. Okay, and then so our last line here in this code is probably the line that like everyone usually gets mad about if they miss it on an exam, because it's the line that a lot of people miss a lot. So what do we think this line is? In a higher order function, would you always need the return statement to be? Yeah, perfect. So a lot of people really miss this. So when you're writing a higher order function, please, please, please remember to write return and then the inner function. Otherwise, this inner function will never be called, which is really sad because you spent a lot of time writing that code. Yeah. All right. And then as a short little fun aside, how do we write this entire thing as one line? Because 61A loves writing things in one lines. Yes, indeed. We need to use a lambda. So I'll show you the answer to it and then we'll walk through step by step exactly what that answer means. So it's really long. I'm very sorry about it, but it's return lambda of n. So this is one function, right? So we see lambda, our parameter n, and then this is our return statement, right? So if we see lambda of n, f of n floor divided by 10 if n mod 10 equals forbidden. So this is like our if case right here, this part right here. And then else, if n mod 10 is not equal to forbidden, then we return f of n. So if we walk through that on our slides, we can see our return value if the if clause is true. So our if clause is n mod 10 equals forbidden. And then this is our if clause. So it's the condition that we're checking for. And then this is our return value if that if clause evaluates to false. So it's just a way to write like an if else statement on one line. Yeah. All right. It is 7 p.m. Thank you so much for coming. Please sign up for CSM section if you haven't already. There's the ed post linked on here for more information. And yeah, if you have any questions at all, please post on the ed stem for our review session. We'd love to answer them. And please, good luck on the midterm. Yeah. All right. Thank you so much for coming.